Hi, Assalamualaikum warahmatullahi wabarakatuh. In this video, we are going to look at another problem of finding the area of a region that lies between the graph of two functions, and we are going to look at the third scenario here. So, according to the statement given here, some regions are best treated by re-expressing the given functions as x equals to fy and x equals to gy, and then you will go on and find the boundary where y is equal to c and y is equal to d. So in this case, fy here is always greater than or equal to gy, and then you'll be able to integrate it with respect to y. So this is actually the same idea which is given on this slide here, on this one, except that this integration is with respect to x, okay, because clearly you can see that this is fx is always bigger or larger than gx, so you'll be able to get the area under the curve, and this is done with respect to x because you can find the limit, the boundary here, where x is equal to a and x is equal to b. On the other hand, sometimes you may also get the area, for example as this one here, where you can see that it is best if you integrate that with respect to y instead of x. So if you want to integrate that with respect to y, then you have to re-express, you have to rewrite the function given so that x here becomes the subject, so that the function here depends on y, and the same thing for this one, x becomes the subject so that we have a function in terms of y. So you can see based on this one here, you're going to integrate that with respect to y, so you have to recognize what is the limit for y. So y can be equals to d, so d is the upper limit, and y equals to c, so c is the lower limit. And clearly you can see that this is the function here, so fy here is always greater than gy, so fy is greater than gy, and so we have fy minus gy. Okay, all right, now we are going to apply this to example 6.10. Okay, so in this example, you are required to find the green shaded area as demonstrated in the figure below. So you can see that clearly if you integrate that with respect to y, it is easier to determine the boundaries and so on. So you can see that this is the intersection point here. So based on that, this is the limit, y equals to 4, so this is y equals to 4, and there's another one, so this one is the limit where y is equal to -2, so this is y is equal to -2. Next, I think you can clearly see that this is going to be your fx, this one, because this is bigger than this curve, so this is your fx, and this is going to be your gx, so this is your gx. Okay, all right, let us apply and put all the information into the proper formula here. So what we have now is we are going to integrate this function here. Okay, let me just choose a better color. So we are going to integrate a function here, which is fy minus gy with respect to dy, and we know that the limit is going to be between -2 and 4. So what is fy? So this is fy. It is given by y is equal to x minus 1, but we have to re-express it so that x becomes the subject. So in this case, we know that x is equal to y plus 1. So that's the first function, which is y plus 1. This is fy minus, so we are going to minus with this function. This function is given as, okay, um, I need to erase this part because I cannot see the function. Okay, so this function is y is equal to 2x plus 6. So we need to rewrite this so that x becomes the subject. So therefore, 2x is equal to y squared minus 6. And so x is just y squared over 2 minus 3. So that is your gy. So y squared over 2 minus 3. Okay. Next, we can simplify what we have. Oops. We can simplify what we have inside here. So that becomes 4. This is negative 2. So this is y minus y squared over 2. Y minus y squared over 2. This one is plus 1 minus negative 3. So plus 1 plus 3, which is plus 4. So I'm just simplifying the expression inside here. Next, I'm going to integrate that, and you will get this equal to y squared over 2 minus y cubed over 6 plus 4y evaluated at 4 and negative 2. Okay, next you substitute 4 into this expression here, so you will get 16 over 2 minus, this is 64 over 6 plus 4 times 4 is 16. Next, minus, subtract with substitute negative 2 into this expression. You will get 4 over 2 minus, this one is, you will get negative 2 to the power of 3 is negative 8. So plus 8 over 6. This one is going to be minus 8. Okay, so if you punch in these numbers into your calculator, you will get this equal to 40 over 3 minus this one is a negative 14 over 3. So that will give us 40 over 3 plus 14 over 3. So that is 54 over 3, which is equal to 18. Alright, that's all for now. Thank you very much for watching.